Good afternoon, everyone, and welcome to the Office of the Chief Scientist Seminar Series. I'm Andrew Paul and am a Senior Science Advisor with the office as well as the host for this fall's seminar series. I'd just like to start by acknowledging that in Alberta, we are within the traditional lands and gathering place for Treaty 4, Treaty 6, Treaty 7, Treaty 8, and Treaty 10, as well as the homeland of the Métis. Wherever you might find yourself today, I ask that everyone recognize and acknowledge the relationship that First Nations, Inuit, and Métis have with the land upon which we all live, work, and learn. Alberta's chief scientist provides these seminars to exchange knowledge on science that's happening across Alberta in an open learning and sharing environment. The intent is that from the dialogue that we have today and throughout these seminar series, we build our awareness and understanding and put that knowledge back into practice through evidence-informed decision-making. In order to maintain the call quality throughout the presentation today, we've had to disable your video and audio, but please enter questions or comments that you might have during today's presentation at any time through the chat window in Teams. I'll hold all of those questions and comments until the end of today's presentation, and we'll read them out in the order they were received to today's speaker. And with that, I would like to introduce our speaker today, and that's Brett Boukall, who will be presenting on recovering Alberta's northern leopard frogs, a history of translocations. Brett has been a wildlife biologist for over 20 years. He graduated with a Bachelor of Science from the University of Alberta in 2001 and a Master's of Science from the University of Northern British Columbia in 2006. He's been working as a government biologist since 2008, and his experience ranges from land use policy to grizzly bear management, as well as species at risk. Brett was the Bow Region Senior Wildlife Biologist for the last 10 years and has recently made the move to be a species at risk biologist with the department, where he focuses on northern leopard frogs, piping plovers, loggerhead shrikes, and other sensitive wildlife species in the Foothills and Parkland areas of Alberta. And with that, Brett, I will turn things over to you to start your presentation. Welcome.
Thank you very much, and welcome to everyone who's attending from abroad. So today I'm going to be talking a little bit about the history of translocations that Alberta government has embarked on. And this was summarized in a report that was recently released by the Alberta government. So I'm going to provide an overview of what was done and move on from there. And if I click anything wrong, I apologize. It's my first time at this, so we'll see how it goes. First, I want to stop and give credit where credit is due. Pictured here is Dr. Dave Prescott, whom some of you might know, and Dave worked tirelessly on the northern leopard frog, piping plovers, loggerhead shrikes, and many other species at risk. Right now, he's an avid bumblebeer. And I really want to give credit because as my slide says here, this program in particular and the species at risk program as a whole is indebted to Dave for his vision, his actions, and his leadership on the species at risk file. And it was Dave himself that kind of started and led this translocation program, which I'm reporting on today. So why am I involved here? Well, unfortunately, Dave decided that he didn't want to work forever. And he retired, which allowed me to come along. And as I was getting familiar with this role, there's an old draft, half a draft, that kind of described a lot of the methods that took place 10 years previously. And in talking with Dave and a few other of my colleagues, we had the idea, well, maybe we should report on this. And you know, that's probably one of the learnings is there's a lot of things we've done in the past and we don't always necessarily report on them, but the ideas and the learnings of those can be influential not only of what we did in the past, but also inform what we do in the future. So that's kind of the groundwork for what I'm presenting on today. Just to give you a brief overview of what we're going to talk about, I'm going to talk about the species at risk process in Alberta briefly, because that kind of lays out why we're here and why the government was embarking on a translocation program for northern leopard frogs. We're going to talk about the northern leopard frog recovery actions, specifically to translocation. What was the process that was used for this program? The success or the learnings, I guess, from the translocation. And then where we're going from here, and maybe even a little bit of why we're doing that. So, for those of you not familiar with the Alberta Species at Risk program, it really consists of 6 main pieces. There's a general statusing where all species are assessed for their relative security in Alberta, ranging from a secure species to maybe at risk. Those that are identified as being sensitive or maybe at risk go through a detailed status. As part of that detailed status, if they're considered to be endangered or threatened, they go through a legislative process where they're listed as such, and that listing requires a recovery plan, which then speaks to prevention, and all those pieces followed by the implementation of the various plans. Today in this process, I'm largely focusing a little bit on the recovery planning actions and the implementation of those actions relative to translocation. Like I said, setting the stage for how translocation began. To kind of go a little bit more in depth, I'm sure this is well known, but endangered is a species that's facing imminent extirpation or extinction. So a really good example of a species that's endangered in Alberta is a greater sage-grouse. Perhaps not conversely, but a threatened species is one that's likely to become endangered and face those same risks if the limiting factors are not reversed and recovery can occur. So the northern leopard frog was a species that was identified as being threatened in Alberta. Not quite at the same critical stage as sage-grouse as an example, but limiting enough that actions needed to occur to recover the species, or work towards recovering the species, excuse me. So recovering plan implementation. One of the major implications of the Wildlife Act listing as endangered is that a recovery plan must be produced. So the plan comes up, it lists the biology, it identifies major threats, but it also comes up with goals and objectives and an action plan, specific tasks of what needs to be done to recover or maintain that species in the province. It's more or less the blueprint for how to recover a species. And broadly, these plans cover 4 main types of actions: habitat management and protection, population conservation, research, and information and outreach. And I think it's really important to recognize that we're not doing this in silos. All of our implementation involves building partnerships amongst governments, with industry, land managers, and landowners in order to achieve a successful outcome. So when we move to implementation, it's really important to understand, well, what are we trying to achieve? And in this case, are we working towards a maintenance or a recovery goal? So a maintenance would be a species that perhaps was never widely abundant or never abundant or widely distributed. So here I have a picture of the piping plover. These are quite limited in Alberta, known from more than a handful of lakes, but few. And so largely the recovery plan focuses on a maintenance goal. How do we maintain this species in Alberta? Conversely, we have a northern leopard frog where we've definitely noticed the species have experienced declines, but largely we're trying to focus on stabilizing or even recovering the population. So often in these plans, we have a recovery goal. Now, the northern leopard frog recovery, pictured here kind of in the hazy purple pink, is what we believe to be their historical range in Alberta, primarily covering the Grassland and Parkland natural regions of the province. Now, the northern leopard frog rapidly declined in the 70s and 80s. We haven't been able to identify a clear cause yet of what was responsible, but we believe it was a multitude of factors, probably occurring perhaps all at once. Habitat loss, increase of agricultural intensification and loss of wetlands, pollutants, the increase in the use of pesticides, herbicides, especially in the 70s and 80s with some of our organochlorine pesticides that were being used, disease, the rise of factors such as chytrid fungus, and many others, climate change, are all believed to have an impact to not only northern leopard frogs, but amphibians as a whole. So we saw our populations plummet. Now, interestingly, our populations probably weren't well monitored. Not probably. They weren't well monitored in the 70s and 80s. And it was kind of anecdotal observations that said, wow, where did all the frogs go? They're not here anymore. And that caused us to realize that our frog numbers had disappeared. This current is the blue is our current range. Admittedly, these blue dots here that I'm showing, whereas what was observed in 2001 during a provincial census is we had even a smaller range. There's approximately 55 sites that we were able to observe northern leopard frogs occupying. On the basis of that, we had kind of said, well, our frogs are disappearing. They were listed as threatened in 2003. And the subsequent recovery plan included many actions to help recover the northern leopard frog population, including translocation as one of the key actions identified. So, the recovery plan, planning to action. So, like I just mentioned, translocation was identified as a key strategy in the recovery plan, right? We're going to translocate and move frogs to increase their distribution. Now, when we're talking about translocation, I think it's important to recognize there's a few types of translocations that are used, but we're talking about a conservation goal, and we're talking about the movement of organisms for the purpose of yielding a quantifiable conservation benefit, right from the IUCN guidelines. And I say this purposefully as opposed to a conflict translocation where you're moving animals that might be in the way due to conflict, whether that be from development, human development, or from getting into conflict with some other public purpose. Now, translocation wasn't necessarily new, and it had been occurring for some years based on some of the reports as early as the early 90s where frogs were kind of moved around, but there wasn't much success. In the early 2000s, after one of the initial census, there was a great deal of effort, and the images shown here show a frog pen, a breeding pen that was used at the Raven Brood Station hatchery, which is just south of Caroline, where frogs were grown and then released at various sites. Now, largely they were released as adults, and the summary of that work was it just didn't end up being very successful. Frogs never took in the places they were released at. And we have gone back to those sites recently in the last few years, and we can't detect any northern leopard frogs in areas that were released. However, one was successful, and this one occurred very locally, where eggs were taken from one site and moved to another site near McGrath, where they found eggs, and they said, okay, we're going to take eggs and move these eggs into it. That way that gives the frogs a chance to breed and hopefully be successful. And it was. Over a 2-year period, the movement of eggs into the pond near McGrath allowed the frogs to breed successfully, and McGrath is crawling in northern leopard frogs now because of that work. And so that set the stage for a reintroduction strategy. And this was a document put together by Chris Kendall and Dave Prescott in the mid-2000s that kind of describes how translocation efforts could occur and the process that the province would embark upon. So what was that process? Well, the first part of that process is to assess sites within occupied watersheds. So we're not talking about increasing the range of northern leopard frogs, but we're concentrating on strengthening, making now those populations sustainable within its known range. So at the time in 2006, when this was initiated, 45 sites were assessed, largely by desktop, but also other manners to assess and identify, well, where are some potential sites that we can potentially move northern leopard frogs to that we believe would be successful. So items like habitat were assessed, accessibility, land protection status, moving them to an area that's going to become a city residential lot might not be a good idea. I'm being hyperbolic at this point, but those are the kind of thoughts that went into the initial assessment. Then they went through all those 45 sites and they figured out that what sites would be the best. And so they went through and they identified 14 sites that were highly suitable. So they ranked high from a perceived habitat point. They had land protection. They were accessible so that you could bring frog eggs to them. And then those 14 sites were assessed for winter dissolved oxygen. Why winter dissolved oxygen? Well, northern leopard frogs, unlike some of our other frog species, occur over winter in the water column itself, and they require an oxygen level to sustain them. So having sites that freeze to the bottom or low oxygen wouldn't be very suitable. So they used, sites with greater than a dissolved oxygen of greater than 5 parts per million. And this was based on known sites that were sampled as well, where we have known northern leopard frog populations. So we said, okay, 5 sites or sites greater than 5 parts per million, okay. So we then selected those sites, and altogether there were 9 sites that were selected as being suitable with a dissolved oxygen concentration in the winter, enough to sustain overwintering frogs. So in this image, below you can see where our sites that we want to locate frogs to, as well as where they're coming from in the triangles, the donor sites. And this process took place over several years, from 2006 to 2013. So after all of that desktop work and assessing, we finally moved to translocation. So egg masses were collected from known sites, and the object was to not cause a impact or maybe a sustainable harvest of eggs from those sites. So they aimed to take less than 10% of the egg masses that were observed to be in the area, and those were transferred. And translocations then occurred over 2 years. And each site received at least 2 egg masses in each successive year. So egg masses were gathered and moved to an identified site, and that happened 2 years in a row. And then when the egg masses were collected, they were released into an enclosure basket, pictured here in the middle. You can see them collecting the eggs in the cooler. It's then moved into a predator exclosure basket, which is placed at the translocated site, and then that site is monitored, and after hatching, the tadpoles are then released, and they're spread out across the translocation site, so as not to put all the I guess quite literally eggs in one basket. And so they were released across the area. What was found is that at the same time that this translocation was occurring, there was new discovery about chytrid fungus affecting populations, not only here, but across the world, and amphibians. And they found that this process was really effective at reducing disease exposure by moving the eggs as opposed to adults. So what did we learn? Well, perhaps unsurprisingly, after monitoring for 2 years, hatching and metamorphosis occurred at all sites. I say unsurprisingly because at that point, tadpoles were released, and those tadpoles, of course, metamorphosized into adults. And that occurred at all sites. However, overwintering survival was only observed at 7 of the 9 sites, so already a decrease. And then further, reproduction the following spring was only observed at 5 of the sites. So frogs were released over 2 years. They were monitored successfully. After 2 years post-release, we were only able to determine that success occurred at 5 of these sites. So 55%, roughly half. I came into this program late, 2022, excuse me, and we decided to go back. Like I said, my bright idea, let's go back to all these sites. We went back to all these sites again, and interestingly, we had the same results in terms of the success, is that 5 of the 9 sites, the same 9 sites, were successful in finding young or breeding frogs in the area. And I will say that during the monitoring, they were monitored by the image on your left is a recording unit. So we were monitoring them by breeding sounds as well as by young of the year surveys and actively looking for frogs visually. So throughout this process, what did we learn? Well, our success rate was actually aligned with a lot of the other translocations that have occurred throughout literature. Roughly 50% seems to be the average, and so we were kind of right along with some of the other successes that have occurred for other amphibian translocations, excuse me. The success was not related to the number of eggs nor tadpoles transferred. So we did count the number of egg masses that were transferred, and we, as well as the tadpoles, and we related that to success. And there was no relationship between how many eggs, which is important because if your site's not good, it doesn't matter how many eggs you put on the site, it's just not going to be successful, excuse me. Conversely, having the right site, you can also reduce the number of eggs potentially you move forward in a future. So that's an important knowing that the number of eggs their tadpoles transferred wasn't a big determinant of success. Interestingly, once successful, these sites were sustainable in the fact that we went back after 10 plus years and found that they were still breeding, which is important for the sustainability of any such program. What else did we learn? Well, reservoirs were surprisingly not successful for reintroduction. The one site that was a reservoir kind of got modified halfway through in that the reservoir berm was removed and it became kind of more of a wetland with a creek flowing through it. I'm not sure how much that impacted the success or not, but why weren't reservoirs successful? This was a little bit confusing, and admittedly, I don't think we have a very clear answer. Because we do know that some of our reservoirs, including some of the donor sites that we gathered eggs from, are reservoirs. So why weren't they working for a reintroduction effort? Was it a cause of maybe not fish? I don't want to put the blame on fish, but predators? Perhaps. Maybe we could have done a better assessment of viable breeding habitat. Maybe the overwintering viability that we believe to be the case may not have been present there. Perhaps the dissolved oxygen, which would have been in the stratified for habitats where the frogs would have resided, wasn't as high as necessary. We're not really sure why reservoirs weren't, but they generally weren't successful. Movement of eggs did lead to improved outcomes, especially relative to the risk of disease transfer. Going back to these sites in 2010, these sites still, while chytrid fungus is very prevalent throughout Alberta, due to some work of Dave Prescott and Scott Stevens, and these sites were still not where they were transferred. chytrid fungus was not readily observed. I think the other piece is that conservation translocation in general, it's an intensive work. You really have to be willing to make a large investment, not only in assessing suitability, but also in understanding movements of the translocated individuals and future monitoring as well. Success remained through time. Once they were successful in breeding after the initial 2 years and going back 10 years later, they were still productive. Once again, the sustainability of it was kind of impressive. Interestingly, recognizing that we have a low sample size, 9 sites, of which 5 are successful, the 5 that were successful tended to be located in riparian habitats along flowing waters. So oxbows, some of these other collections tended to be perhaps more successful than some of the other pieces. Once again, we haven't understood why reservoirs weren't successful, but definitely did notice that lotic systems, or habitats associated with lotic systems, tended to be better. But some questions arose. So, like I said, our program was successful. Our methodology appeared to work, and we are seeing, so right now in this image here, you can see this is Beauvais Lake near Pincher Creek, and the green spot that maybe you can just barely see, should have made that bigger, apologies, was where the initial relocation occurred. And you can see all the red triangles in the subsequent years as populations appear to have spread from this site, and they're now being observed in the neighboring creeks. So we're starting to see expansion of northern leopard frogs into different areas from their initial translocation site. But we're also stuck with the success versus recovery. So when I went in 2023 to assess the success of these 10 years later, I didn't find them. And this is a picture of one of the reservoirs. The green dot shows where they were observed, and we didn't find them there, and kind of had, using both the ARU and visual monitoring, didn't see them. But later that same summer, there was an observation approximately 5 kilometers away. And the following year, another observation 5 kilometers away, shown by those red dots there. And I will note that these weren't just single individuals. These were breeding young, or not breeding young. These were young of the year, evidence of breeding, So are these frogs that were perhaps that we moved during translocations, didn't like the habitat that we put them in and found other habitat? Potentially, and we just had never surveyed there. Or are these frogs that have naturally filled in this habitat from other areas? Once again, it's 10 years after the fact, but it does kind of raise some questions about understanding frog movement, and as well as understanding frog detection. I think our ability to detect frogs, northern leopard frogs, has much improved with technologies that didn't exist 15 years ago. But we're still faced with this question now of maybe we were successful, or maybe frogs are naturally occurring and this wasn't as successful at creating more populations and increasing the distribution. Now, in 2006, the known locations of northern leopard frog looked very different from today. It was absent, as I've shown earlier, from much of its known range, and 55 spots that we had known to have northern leopard frogs were largely confined to the corner of southeast Alberta. So you can see here by the blue dots is where frogs were found during the 2000-2001 survey, and the green stars are where translocation efforts occurred in the subsequent following years. A lot of these were attempting to place within the existing range of northern leopard frogs. And that's what drove our translocation efforts. However, fast forward 15 years, perhaps less, and northern leopard frog are now present throughout much of southern Alberta. And where we had 55 spots identified with northern leopard frog, we now have sites that have been occupied at least once or more 220 times. So our map looks a lot different in terms of distribution. So northern leopard frog appear to be trending in the right direction. Using a measure of area of occupancy, which is a measurement of how much of a species range is being occupied, using the same criterion of 2 by 2 kilometer grids, we can see that prior to 1990, we roughly had AOO of almost 800. Now, this was part of the measurement that initially informed the decision to list northern leopard frogs. And by 2000 to 2001, that same had dropped below 400. Since that time, we've started to see an increase. And so bear with me, as this is kind of we're just kind of preliminarily looking at this. But looking at decadal observations, by 2010, we'd seen the AOO rise to above 800 kilometers squared occupied to now over 1,000 by 2020. And so there's a linear improvement over time. And then key sites, which we've identified of having more than one observation and a presence of young. So these are our key sites that are going to be in a metapopulation dynamic, kind of our sites from which colonizing occurs from. We have an AOO of 580. And I use that, just the red bar of key sites in comparison to 2001 is that it's approximately 1/3 larger. So we've definitely seen an improvement of just looking at that. Like I said, this is really preliminary, and we're still kind of investigating what this actually might mean for the population. But it does appear to be resulting in an improved outlook. So what does this mean for translocation? Well, our program ended in 2014, and it really hasn't been initiated. Looking now at the improved outlook that I just kind of preliminarily outlined, there's definitely a reduced conservation need for a sustained translocation program in Alberta. Northern leopard frog appear to be occupying habitats on their own, which is great news. Why that's occurring, I think we're just starting to investigate and hoping to understand. But the same need that existed in 2006 no longer appears to be there for a translocation program. But we now have the tool that exists, and we've done some work over time to say, all right, we can make this tool work. We can move eggs if we need to. We can look and see where frogs are. And showing in the lower right corner is a habitat suitability indice model that we're currently in the process of verifying. And having models such as this, focusing perhaps less on land protection and more on where habitat is, perhaps less on reservoirs, can all help us move forward if we need to go back to a translocation program. So what is the future of our northern leopard frog program? Well, we're going to focus on perhaps surveying more in our gaps in our existing range and potentially even looking at range expansion. Secondly, because, as I said, the information on the area of occupancy was fairly preliminary, we want to look more robustly and determine where our population is heading, perhaps using models such as occupation modeling. From a gap perspective, these are some of the areas in red here that we're hoping to focus a little bit more on to understand where these gaps exist, and if they're a function of just not enough survey effort or not enough habitat for frogs. And with that, that concludes my presentation, and I guess I'll open the floor back up to Andy to answer any questions that might have arisen.
Thanks very much, Brett. That was an excellent presentation. With that, I should wrap up our seminar today. I need to remind folks that there will be no seminar in 2 weeks, in observance of Remembrance Day. So the next seminar is going to be on Tuesday, November 25th, where we'll have Travis Tukarik presenting on a historical analysis of volatile organic compounds, insights from data collected in Edmonton and Calgary. I want to remind folks, if you are not on the mailing list and would like to be added to the mailing list for these science seminars, please send an email to epa.ocs@gov.ab.ca. I do remind you that these presentations are posted on YouTube, so if you know a colleague that had to miss today's presentation, would like to see it, they can find them. It's usually posted within a week on the EPA YouTube channel. And with that, we'll end today's seminar. And again, thanks, Brett, for a great talk and great discussion. Thank you, everyone.
Thank you.